Normalize the wave function psi of x equal x into bracket L minus x for a particle in a box with length L. We are looking at the 100% probability of finding a particle in a box of length L. For a box of length L, we know that the probability of finding the particle outside the box is going to be 0%. And the chances of finding it in the box is to L. So our limit of integration is 0 to L. And the probability of us to find the particle, 100% probability of finding a particle in the box equal integral from 0 to L. That is our limit of integration of absolute psi of x squared dx equal 1. But in this case, the normalization constant has to be included. We need a constant that when we multiply it by this wave function, it will be normalized. It will give us 100% probability of finding a particle in a small space. So we have to include the normalization constant. So let's say our normalization constant is n. So the wave function should be of this format. When it is normalized, nx, just multiply n by it, L minus x. So now we are going to take this wave function and solve for the normalization constant. So integral from from 0 to L equal psi of x squared. When normalized, this is what we are supposed to get. So we are going to take this absolute square of that because we want to solve for the n, the constant that we multiply by this to make it normalized or to make it useful for describing physical systems. All squared dx equal 1. So anytime we are talking about a particle in a box, you should know that there is 0 chance of finding the particle in the box, outside the box, and there's L chance of finding the particle in the box. If you are not given the length of the box, then you can decide to choose 1, meaning, there is 100% of finding the particle in the box. So now let's square whatever is under the absolute sign. So squaring this whole thing, they've raised to the power 2. So n to the power 2 gives us n squared. X to the power 2 gives us x squared. All into bracket, L minus x to the power 2, the x equal 1. Since n is a constant, let's factor it out. So integral from 0 to L, n squared, x squared into bracket L minus x to the power 2, the x equal 1. If we have a term a minus b to the power 2 and we want to simplify it, we square the first term a to the power 2 and we multiply 2 by a by minus b, giving us minus 2ab, and we square the last term b squared. So let's apply this idea here. So we are going to have n squared integral from 0 to L, x squared, so L to the power 2 L squared plus 2 multiplied by L multiplied by minus x, that will give us minus 2 Lx plus negative x to the power 2, giving us x to the power 2. The x equal 1. So now let's expand the bracket, multiplying 2 by x squared. So we are going to get n squared integral from 0 to L. X squared multiplied by L squared gives us L squared x squared. X squared multiplied by 2Lx minus 2Lx to the power 3. Since of that they are of the same basis, we add their powers. So x squared multiplied by x squared gives us x to the power 4. So the x should give us 1. So now integrating, if I have x to the power 4 and I'm integrating, it's going to give me x to the power 5 over 5. The power increased by 1 divided by, everything divided by the power, the increased power. So now let's do the same here. So we are going to get n squared So we are integrating with respect to x. So we are going to get L squared. X to the power 2 gives us x to the power 3. Then we divide everything by 3 minus 2L x to the power 3. Integrating it gives us L to the power x to the power 4 all over 4 to plus x to the power 4. Integrating it gives us x to the power 5 over 5. And our limit of integration is from 0 to L equal 1. So now let's introduce our limit of integration. First, we start with the upper limit. So n squared limit. So wherever we see x, we replace it by L. So we have L to the power 2, x to the power 3 becomes L to the power 3 all over 3. Here we have minus 2 over 4. 2 can cancel out. Here 1, 2 goes here 2. So we can just write 1 Lx, which is the same as Lx, but we are replacing x with L. So L to the power 4 all over 2 plus x to the power 5 becomes L to the power 5, L to the power 5 all over 5 into bracket minus, we now put in the lower limit. Wherever we see x, we replace it by 0. So L multiplied by x to the power 0, x to the power 2, multiplied by x 0 to the power 3, all over 3 minus L x to the power 4. We've simplified this place to be 1 over 2. So all on 2 plus x to the power 5 becomes x to the power 0 to the power 5 all over 5 equal 1. So this whole term here, this becomes 0, this becomes 0, this also becomes 0. So now we can just write this out in terms of this. So n to the power 2, L to the power 2 multiply L to the power 3 gives us L to the power 5, right? L to the power 5 over 3. L multiplied by L to the power 4 gives us negative L to the power 5 over 2 plus L to the power 5 over 5. Since this whole term is 0, so you can just equate it to 1. So now let's factor L to the power 5 out. So n squared L to the power 5 into bracket. This place becomes 1 over 3 minus 1 over 2 plus 1 over 5 equal 1. So let's add whatever is in the bracket. So we are going to get 1 over 30. So n squared L to the power 5, 1 over 30 and equal 1. So multiplying both sides by 30, both sides of the equation by 30, this will take care of that. And then we are going to get n to the power 2 L to the power 5 equal 30. And now we want to divide both sides of the equation by L to the power 5. So L to the power 5. So this will take care of that. We are going to get n to the power 2, n to the power 2 equal 30 over L to the power 5. So taking square root of both sides, this will cancel that. N is going to give us 30 over L to the power 5, L to the power 5 or the square root sign. So this now is our normalization constant for this question. The question asks us to normalize the wave function. To normalizing the wave function, the question didn't indicate any letter for us for the normalization constant, and we decided that n should be our normalization constant. We just multiply it by the given wave function and take the absolute square of that and integrate with the given limits to get our normalization constant. Now we can go ahead and write the normalized wave function as this. We were looking for a constant that when multiplied with the wave function would be able to describe a real system. It won't give us a negative probability, but a positive 100 probability of finding a particle in the box, because the particle is in the box. That is if it exists in the box. So now we are going to write our normalization constant and then x to bracket L minus x. So square root of 30 over L to the power 5 multiplying x into bracket L minus x. So this is our normalized wave function. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.